Hi everyone, this is Crispy1001 at kpcoolstuff.com. This is our 24th video on how to use Blender and the Blender2FSX add-on to make models for Flight Simulator 10. In this video we're going to be making a 3D gauge, coding it, and animating. So let's get started. So the steps we'll be taking to make this. We're not going to do the modeling part of it, but you would have to decide what your gauge will look like and then model it. Then we're going to have to find the code in the model def file close to what you want your animation to be like, or what you want your instrument to be like. Find a simulation or simulator variable in the SDK. Then we're going to have to calculate the calibration code for the instrument needle movement. We will write our animation code in the model def file, apply the animation tag to the animated needle, and then animate the needle, and then you'd want to test your instrument in the flight simulator. Now number 7 I can't do because Flight Simulator doesn't run well with the screen capture tool that I'm using. So let's open up Blender, and you would have to already have a gauge modeled. Now I will make this file here, Blender file, available as soon as I can for people to use as a teaching guide on how to do animation of 3D gauges, switches, and all the other things I have in this panel, or this instrument panel. But we're going to be working on the airspeed right now. The background can be made with I used GIMP 2.8, or you can use Photoshop. You can also go on the internet and see if you can find something close to what you want. I set mine up because I'm going to be doing kilometers per hour. So first thing we'll do, we're going to, I've already clicked it in. You want to open up or first go to your Blender2FSX tab, open up the FSX animation tool and type in needle. And we're going to find something that is close to our airspeed instrument. And that's what ASI stands for, needle airspeed instrument. And we'll keep scrolling down. See if I can find it. There it is. That's the one I want to use right there. Or not use. I'm going to remember this name. I'm going to go into the model def file, find that, and I'm going to use its code, paste it in a new location, and change it to work for me the way I want my instrument to work. So we're going to remember needle underscore ASI underscore EH101. We can minimize this right now. We're going to go to our model def file, and you will find that if you did a default install for the Flight Simulator SDK, it'll be under C drive, Program Files x86, Microsoft Games, Flight Simulator 10 SDK, Environment Kit, Modeling SDK, bin. Then before you do any modifications to your model def file, make sure you make a copy of it. So make a copy, do a right mouse click, copy, and then paste it in. So we would open that, and then make sure that you're at the top of your file, hit edit and find. A find window will open, and paste in that needle underscore ASI underscore EH101, hit find next. is right here. You want to go all the way down to the backslash and the greater than sign. So take this part here, do a right mouse click and copy. And you'd want to go all the way down. Well, actually, you can open up another one. So let's go and do this. Let's go copy. We'll open up another notepad. Control V to paste it. And enter down a couple times. Then we want to hit Find Next again. And then here you want to go from Part Info down to Part Info. So these areas here you want to go copy and paste. Close that. I'm going to scroll down to where I already have mine done, but I'm going to show you how I got to this point. So I'm going to minimize this one. Okay, so now we have the code that we're going to be using for our own. So we would want to change this to what we want. So you would name this whatever you want. So let's do my underscore ASI. And you'd want to copy that. You'd want to put it also under your type parameter 2 and under your name under the part info. Okay, so we have that part done. Next we need to get, let's see, let me delete some white space. Next we need to get a new guide number. We do not want to use this one in case we ever want to use that needle underscore ASI underscore EH101 animation. And if we use this one and that one for some reason, we could have issues. So we want to delete that gauge number. We want to go back to Blender and of course you'd want to open up a new Blender file. If you already have a guide set up for this 3D, your project you're doing, you don't want to redo it. So we would go ahead and minimize that, open another version of Blender, and go down to Blender and generate guide. Oops, click on it, do a Control C and enter, and we can go ahead and close this one. Don't want to save nothing, and we come right here and do a Control V. Now we have a new guide. We have our sim type autoplay, length of 200. That's good. I want to leave it 200. And we will make sure this is 200. And now we want to create our code. Now this is under knots. I don't want knots. I want to have kilometers per hour. So I'm going to delete this here. And we're going to have to put under code and we'll add our code right here. So the next thing we need to do, we need to look at our gauge. So let's open up our gauge, or open a picture of our gauge we're going to be using, which is right here. Now we're doing kilometers per hour. Our maximum speed for this is 260 kilometers per hour. So we want to remember that. But because our code that we're going to be using, we'll have to go find our code next, or our variable, our variable that we're going to be using. So we want to go to Simulation Variables. Oh, I need to show you how to get there. Okay, let's go back to our SDK. So you would navigate back to your SDK. You would go to Core Utility Kit, Variables, and click on Simulation Variables. Once you did that, this window here would open. You'd scroll all the way down to where you have Aircraft Flight Instrument Data. And I don't want true airspeed, I wanted the indicated, airspeed indicated. Now the difference in between those, I believe, the true airspeed is the speed which your aircraft is moving forward itself, not including wind that may already be blowing. Airspeed indicated is your aircraft's speed plus or minus the airspeed that is blowing, or the wind that is blowing. So let's say that your plane is moving 80 miles per hour, or 80 kilometers an hour forward, but you have a headwind of 20 kilometers per hour. So that would give you a indicated speed of 100 kilometers per hour. If you did an airspeed true, you would only be at 80. So I'm going with this one here, so you want to copy this, and I believe it's A. Let me go back and look at my other one, because let's see, nope, wrong one. Okay, it's A before. So we go there, we go A, then colon, or I think that's, yeah, colon. Then we want to go Control V. So that's our variable from the simulator, airspeed indicated. Then we want to do a comma, and now we need to know the units of measure. So we want to go back to the simulation variables, and under units we see that it is knots. So we want to copy knots, go copy. We can minimize that now. Control V to paste it, and then end it there. Now this would give us the speed in knots only, but I need it in kilometers per hour. So now we need to come up with a formula for that. So if we go back down, and I'll try to explain how I did it, and there's several websites I used for converting knots to kilometers per hour and kilometers per hour to knots. And these are right here and right here. So what I did, I know that my maximum kilometers per hour is 260. So I know that my variable give me units in knots. So I need to know what was my maximum knots for that 260. Well, approximately it's 140 knots. So then I need to find out how many knots do I need for my needle to move per keyframe. Now I know the maximum keyframes I used is 200. So you have knots per frame, which is 140 divided by 200 keyframes, which gives me 0.070 knots per frame, or per keyframe. But I need that in kilometers per hour. So I take the 0.70 knots, and I have to multiply it by a factor to get my kilometers per hour. So if you go up and you look at right here, knots converted to kilometers per hour, and that's 1.296 knots for 0.070, or I'm sorry, for every 0.70 knots, you'd be going 1.296 kilometers per hour. So you take this number here, and you want to have for every frame now, or every keyframe, you want to increment it by 1.296 kilometers per hour. So now we would go here, and we put in that, oops, what was it? Well, I'll just go ahead and copy and paste, and then I'm going to tell it to multiply. So what this is doing, this is taking the variable airspeed indicated, which is in the units of knots. It's taking that number from that variable and multiplying it by 1.296. So that's how we're getting our airspeed movement for the needle animation. Now, of course, you may have to calibrate a little more with that by fudging, going into Flight Simulator, seeing how close you are. Go to Map, see what your airspeed is, but it'll be in miles per hour, I think, depending on how you have Flight Simulator set up. Convert it, find how close you are, and then adjust this calibration number until you get it as close as you desire to get it. So that's what we get here. So now we basically have our code for our needle. So we want to take this and go copy and go to your model def file and paste it at the bottom. Once you paste it in, it should look like something just like this here, except of course your guide number will be different than mine. But now we have our code set up. Now I named mine Jadel Needle _ ASI. So now we have our code set up for that gauge, or for that instrument. So we can save that, and we can close it. Open up Blender, and you will have to initialize the tool set to find it, because if you don't, you will not see it. Then you remember what you named yours. Remember, I did mine Jadel. And let's see where it's at. There it is, Jadel Needle Airspeed Indicator. So I'm going to click on it, make sure I have my needle selected, no animation tag at this point. I'm going to assign. Okay, there we go. So Jadel Needle ASI, length of 0 to 200 frames. So now we're going to have to set it up down here. So with your needle straight up at the starting position on your instrument, let's add a keyframe. So I and rotation. Then we need to rotate our needle, but we're going to go to half of that. So I'm going to split it and do a keyframe at 100 and that ending at 200. So we're going to move our animation to 100. We're going to rotate on the y-axis, so rotate y and rotate it. I'm going to put it about halfway. I'm going to insert another keyframe, so I and rotation. I'm going to move this to 200. I'm going to rotate again on the y-axis, and I'm only going to go to the maximum speed of my instrument, which is right there. I and insert another keyframe for rotation. Now we put it to 0 and play it. And that works good. Let's put it back to 0. Okay, so now we can hit save. And that is how you set up an instrument or an airspeed instrument. You could now test this in Flight Simulator after you went and did export, make your model file. So you go to Model, Export Model, and Export, and then test it in FSX. Now, just be doing, I'll show you how to do some of the other gauges, because it does make a big difference on your animation. The coding isn't, I mean, the coding of course is different too, but the one I'm having I'm still having to try to calibrate is doing the attitude. So the attitude on this one, of course, you would do again, you would find code that's close to it in the model def, and you'd make it for yourself how you want it to work. But the animation of this one is the part that is different. You don't do a full 360 degrees on this one, you only do a 180 degree rotation on the animation. So again, you would find your code, you would write your code how you want it. And I can show you what I have on this code. And if you know how to fix the code better than what I do, please let me know, because I'm having issues trying to calibrate it. So let's go to Model Def, and let's go to my attitude. Turn coordinator. Okay, so this is what I named mine, and here's the code that I have. So I'm taking the attitude indicated bank degrees variable. The units is in degrees, and then this is the code that I have for it. And everything works good, it's just too sensitive on the movement. When you bank, it goes a little too far sometimes. So I'm having to try to figure out how to correct that. So that's the code you'd use for that. But remember, your starting point you want to have, let me play it so you can see which way I animated it. So remember, it's only animated 180 degrees, so, and it's also a length only 0 to 40. Now that may be why it's moving too much. I may need to increase my length of my animated frames. But let's hit play. And you can see it goes only 180 degrees. In the flight simulator, at 0, it will put that animation and start it on the at 90 degrees. So not at, it'll start it more at, let's go back. There we go, on the 20th frame. That's what it'll, that's how it'll set it up in the actual flight simulator. The next thing I animated, let's see, this is altitude. Let's go back to 0. Now this is just bonus stuff I'm showing you here, just on how to animate it. This is the main one that we were going over. But this other information is also good, like this one here. It took me a long time to figure out how to animate this one, because it wasn't like you'd animate this one here. And then the altimeter is also different, because you do a full 360 animation instead of just partial to your maximum movement of your instrument, or an 180 degree like this one. But remember, on this one you're going to have a needle for hundreds and thousands. So let me pull this down and you can see. So there's a needle here, and let's go down. So this one here, I did not make a separate animation for myself. I found in the model def file already needle altitude 100. I applied to it, and it told me what length to make it, 0 to 100 frames, and I did it for a full 360 degree. So I did keyframes on this one at every 20 degrees. So you can see I have a keyframe at 0, then 20, 40, 60, 80, and 100. And then you also have a needle behind this one that is set up for thousands. And you can see needle altitude 1000 and length 0 to 100. and again it's for a full 360 degrees. Both needles are moving at the same rate, so you only see one. And it goes all the way to 100. You put it back to 0. The next one that was a little bit different is the vertical speed. Now this one, because of how it needs to animate in positive and negative, so you can have your speed going down this way, or showing that you are going toward the ground, or your vertical speed going down, vertical speed going up. You would start your animation at a 3 o'clock setting, and you would rotate it 360 degrees from that point. And if we click on it, you can see this one here. Again, I did not make my own instrument for it. I used a needle.vsi for vertical speed instrument that was already in the model def file. And in this one, I did a keyframe at 0, at 70, and 140, because your maximum length is 0 to 140. And then if we hit play again, you can see it'll go 360 degrees starting at a 3 o'clock and then end. So that was a big thing that took me a while to figure out how to do the animations. I couldn't find anything, any information on it, so this was trial and error. The RPMs is nothing really different. This one here again, I did not make my own code for it. It already had a needle RPM for it, so I just attached that animation tag to it. But again, I only did movement to the maximum of my dial, so it's not 360 degrees. So in this one, animation length is 0 to 45. So I have it about 23 or something like that. I tried to split it up as much as I could to do my keyframes. So I have 3 keyframes, 0, I believe 23, and then the 45. So that's how you do that one. We already went over that one. Now the compass is a little bit different. Your needle is not animated. It stays stationary. Your back image, this image here, is the image that is animated. And this one again, I did not make my own code for this one. It was already code in the model def, and I found it cylinder whiskey compass. It shows it has a length of 0 to 360 frames. So this one here, I only did 3 keyframes, and I did it starting at north. Now that may be my problem. I don't know why I'm about 30 degrees off on my compass for some reason, and I'm working on that. But you do a full 360 degree movement, and you do 360 keyframes. So you have a keyframe per degree movement. So I did one starting at 0 at north, being at the top of the needle. I went 180 degrees, did a 180 degree rotation, and then 360 I did another 180 degree rotation for a full 360. The fuel gauges, I did make my own code, but I did find code that was already close to this. And again, just like we did before, I went into the model def, I went into the SDK, found the variable I wanted to use. Let's go ahead and look at the model def. And let's go to, okay, there's the Jadel fuel left tank. I got the guide like I did last time. I have a length of 92. Basically, I took this directly from the code that I copied. And the code, or the variable, I used fuel tank left main level. The units was percent, and that's it. And I also made one for the right, basically the same thing, just named it right, and then of course the variable is different for the right main level tank. And then applied the animation tag to that, and 0 to 92. Did 3 keyframes, and basically you start at your 0% fuel, and this is in percentage, and then animate it up to your full movement of your gauge. So basically at see, this is 92, like 43 or something like that. I went right to 50%, and at the full 92, I was at the very top of my movement. Same thing for this gauge here. So if you watch it play, and that's it. Let's go back to 0. The oil pressure, I also made my own. So Jadel oil pressure, and the code general engine oil pressure 1 is the variable, and PSI is the units. Now I had to do a calibration again like we did on the airspeed. So this is my calibration to get how many keyframes I have for what PSI per movement or frame that I wanted, and this is what I came up with, and it works pretty good. Oh yeah, that's oil pressure. I'm sorry, I went to the wrong thing. We're doing fuel. Oh, wait a minute. We were doing oil pressure. Yeah, I'm sorry. I got confused. Okay, so yeah, that's how I did the oil pressure. And again, you do the animation only from the starting point to your maximum value of your gauge. This one had a 200 length, so I did keyframes at 0, 100, and 200. So at 100 I have a keyframe at mid, and then 200 at maximum. And its movement looks like that. And then the amps, I also made my own. Jadel amps. So here again, make sure you get a new guide. Oh, remember to change your name. I should have told you in all those. Make sure you change your name and all the areas you need to change for your custom code. Then this one, electrical main bus amps, was the variable. Amperes was the unit of measure. And again, I had to do a calibration for it. I think that's about it. So that is how you set up 3D gauges. I hope you've learned something from this video. And the next video will be on animation of wheels. I thank you for watching. Have a nice day.